Hey guys, welcome to your recording today. We're going to look at the interior of the Earth, what is inside the Earth. You should be completing your Nearpod. I'm going to just walk this through with you so you guys know what to do. Again, remember that this Nearpod is graded, and I'm looking to see that you're participating on each slide, answering the questions, and doing all the different activities. So let's get into it with the Earth's layer today. You guys should be pulling your link up that is located on the module for Canvas for today's date. And your essential question is, what is the Earth made of? So we're going to look at the inside, the interior of the Earth and see what it's made of. And we'll get started. We're going to engage by assessing our prior knowledge and explore the theory of plate tectonics. So I want to know, how much do you already know about the Earth's layers? Do you know a lot? Do you know a little? Or not anything? Go ahead and mark your answer. Not a right or wrong answer. It's just for me to gather some information as we start this study. The next question is, write down everything that you know about the creation of the Earth, the layers of the Earth, or the Earth's composition. So while you do this, you can go ahead and pause this recording, but you should write this down. Give you just a minute to do this, and if you need to pause, you absolutely may pause. So I'm going to go to your next slide. So volcanoes are raised parts of land that typically have a crater at the top or vent, and lava, gas, and rock can escape or erupt through that vent. On the next slide, you will visit a volcano in Costa Rica. As you explore, consider how the volcano is different from the land around it. What do you think may have caused this volcano to form? So let's go ahead and look all around. There's your volcano right there. You guys can take a moment to look, take a virtual field trip. See how it looks a little bit different than the land around it. What makes it different? There's that vent top. If you need to pause, you are more than welcome to pause to explore some more. So what do you think might explain the formation of volcanoes on Earth? How did they form? Where did they come from? Again, this is not a right or wrong answer. I'm just curious what you think. I'm going to tell you today in our Nearpod lesson, but I want to know, what do you think? If you need to pause, go ahead. We're going to keep moving. So plate tectonics. The theory of plate tectonics states that the Earth's crust, which we're going to look at, is not a single solid layer. Instead, it is broken up into giant plates. And these plates actually move. The plates move due to the convection current from the molten rock below them. So we've talked about convection currents, right? Where that hot liquid or air will rise and then sink. All right, so earthquake, volcanoes, and the formation of mountains can all be explained by one theory of plate tectonics. So for example, when plates or these collide, okay, one might move below the other. The temperature rises at that zone and the rocks will melt. This forms magma, which collects and rises to the surface because it's lighter than the rock around it. This creates a volcano. So on the next slide, you're going to watch a video and read about plate tectonics. Be sure to scroll down to the interactives below the video. So as you watch, take note of how interactions between plates change our planet.
Around the world, mountains form, volcanoes erupt, and earthquakes shake. Why? The red dots popping up on the screen are recent earthquakes. When you see only a few, they may seem like they're all over the place. But over time, you will start to see a pattern. The Earth's outer shell is divided into pieces called plates. Most volcanoes, mountains, and earthquakes occur where plates meet. Places where plates meet are called plate boundaries. There are 7 major plates, along with countless minor plates. You can see that a plate can be made of both oceanic crust and continental crust. Interactions between plates change our planet.
All right, guys, note that when you scroll down, you guys can actually play where you can see how they slip apart. Okay? You see that? You can see how they collide. You could see spreading apart, 2 plates move apart from each other. And then subduction, 1 plate sinks below the other. Okay? You can also play this game down here and then read more about those plates as well. Okay? So we're going to go back to Nearpod. Explain how interactions between plates shape our planet. So give 2 examples. So you're going to want to give those 2 examples right here. The flow of the mantle causes tectonic plates to move in different directions. When the edges of the plate meets, 4 things can happen. So here would be some examples. Here's 4 examples, but choose 2 of them. Okay? You can go ahead and pause. In order to write your answer. So let's explain and elaborate, okay? So let's talk about inside the layers of the Earth. So if you were to cut the Earth straight down in half, you would be able to see its layers. Below is information about these layers from the inside out. So you have the inner core. This is believed that the solid inner core is composed of iron, nickel, and alloy. The temperature of the Earth's inner core is expected to be above 90,000 degrees Fahrenheit. The outer core, this is a fluid layer around the inner core. It's composed of iron and nickel. The mantle, the mostly solid mantle, is composed of rock. The mantle makes about 84% of the Earth's volume. And then the crust is composed of metamorphic and sedimentary rock. The crust make up less than 1% of the Earth's volume. So the crust is the layer that you live on, okay? So on the next slide, you're gonna watch a video about the layers of the Earth. As you watch, take note of each layer. Look at its thickness, look at what it's made of.
Hello, friends. Today, we'll learn about the layers of the Earth. The Earth is made of 4 layers: the crust, the mantle, inner core, and the outer core. Some of the layers have even more layers inside them and are always moving. Come on, let's start from the outside and move our way in. Whoa! Crust. The crust is the thin outer layer of the Earth where we all live. The crust varies from around 3 to 5 miles thick in the ocean floor to around 25 miles thick on land. Earth's crust is found on the outer surface, and it is made of solid rock and minerals. Mantle. The next layer. The next layer of the Earth is the mantle. The mantle is thicker than the crust at almost 1,900 miles deep and makes up about 85% of the Earth's weight. It is solid rock, but not completely hard. Amazing! The mantle is made up of slightly different silicate rocks with more iron and magnesium. Tectonic plates. The tectonic plates are a combination of the outer mantle and the crust. These plates move very slowly, about a couple of inches per year. The place where the plates touch each other is known as the fault. When the plates move and the boundaries bump up against each other, it may cause an earthquake. Whoa! Outer core. The Earth's outer core is made up of hot liquid iron and nickel and is about 1,400 miles thick. Too thick! The outer core creates something called a magnetic field and makes a protective barrier around the Earth that shields us from the sun's destructive solar wind. That's cool. Now, the inner core. The Earth's inner core is made up of solid iron and nickel and is about 1,500 miles thick. That's too hot, and unbelievably, it's as hot as the sun's surface, around 9,000 to 13,000 degrees Fahrenheit. Now you know a lot about the layers of the Earth. Please drop a like, leave a comment, share the videos, and don't forget to subscribe. Our app, Learning Junction, is available on Play Store. Bye-bye.
All right, so you can see on this diagram, based on what you just watched, I want you to label the Earth layers. You also may draw or add any additional detail you know about each layer. I'm going to give you guys a minute to do so, a couple minutes. So based on what you just watched, what are the layers? I want to see if you guys get this right. So I'm going to check your answers, but it shouldn't be too bad. Hint that this would be your inner core smack dab in the middle, right? After that, your outer core, your mantle, your upper mantle, and then also down here would be the crust. This is where we live on, the continental crust. So you should have drawn or labeled those. Let's talk about convection currents. So the Earth's mantles move in what we call those convection currents. Hot, less dense material near the core rises, pulling that cooler material down. This material in turn heats up and rises, and the current continues. So in the next slide, you're going to watch a video explaining how those convection currents in the mantle cause movement of those plates. So as you watch, I want you guys to take note of the 3 types of plate boundaries that are found on the Earth. So 3 types of plate boundaries, okay?
To understand more about plate tectonics and continental drift, we have to look deep inside the Earth. The Earth's interior consists of several different layers. The inner core, which is believed to be solid iron and which is very hot. The outer core, which is believed to consist of rocky material so hot and under such great pressure that it is in a liquid state. the mantle, which is not as hot as the outer core and not as liquid. The mantle's outermost portion is solid. This is the solid outer portion of the mantle. Above this is the outermost layer of the Earth, the crust. Together, the crust and solid outer portion of the mantle form the Earth's outer shell. They are referred to as the lithosphere. It's not always easy to see the Earth's crust. It's covered by vegetation and the oceans. But if you could drain the Earth's oceans and strip away our planet's vegetation, the Earth might look something like this. Now we can see the Earth's hard outer shell. And if you look closely, you can also see the shell is cracked. The red glowing lines mark the places where the Earth's shell is cracked into tectonic plates. Each plate carries a continent or an ocean basin, or sometimes both. The plates are moving at an average rate of 1 to 2 inches a year in a variety of directions, carrying continents and ocean basins with them. Here's why the plates are moving. Scientists believe material in the mantle is circulating much as it is doing here. The movement may be caused by heat within the mantle. You can get an idea of how heat can cause a circulating movement by watching rice as it boils. What you see happening within this beaker is similar to what's happening within the Earth's mantle. As mantle material moves, perhaps only inches a year, it causes the plates above it to move as well. In some places, plates are moving in opposite directions. They are moving apart. The area where two plates are moving apart is called a divergent boundary. In other places, plates are colliding. The area where two plates are colliding is called a convergent boundary. And in other places, plates slide past each other. This area is called a transform boundary. This is a cross-section of a divergent boundary, the mid-ocean ridge, located beneath the Atlantic Ocean. The North American plate is on the left, and the Eurasian plate is on the right. Scientists believe that as the plates move apart, mantle material called magma rises to fill the gap. Magma is the name we give lava before it erupts from volcanoes, as it is doing here. The magma cools and hardens on the ocean floor, adding new crust to old. And as the seafloor spreads, North America moves farther away from Asia. The highlighted area on this globe shows where magma is surfacing between plate boundaries beneath the oceans, creating a mid-ocean ridge that circles the Earth. The ocean floor spreads in one direction on one side of the ridge, and in the opposite direction on the other. The mid-ocean ridge is where plate material is created. And this is where plate material is destroyed, a convergent boundary. In this cross-section, the plate on the right is carrying an ocean basin and is moving in this direction. The plate on the left is carrying a continent and is moving in the opposite direction. The plate carrying the ocean basin is heavier and is diving beneath the plate carrying the continent. The leading edge of the diving plate is consumed back into the Earth's mantle. When one plate dives beneath another, it is called subduction, and the area where it occurs is called a subduction zone. Subduction may resemble what is happening on this lava lake as sections of hardened crust dive beneath other sections. The highlighted areas on this globe mark convergent boundaries. Subduction is occurring at most of them. These are the areas where plate material is destroyed. Here again are divergent boundaries, where plate material is being created. Again, most of them are beneath the oceans, creating a mid-ocean ridge that circles the globe.
All right, so that talked about the 3 different boundaries. Describe one of them. So based on what they just said, describe one of the boundaries, okay? They mentioned 3, so if you need to go back and watch the video, you can hit this back button. But based on what they just said, describe one of the plate boundaries. If you need to pause me, pause me. But we're going to keep moving. All right, so what's our impact on the Earth's crust? So there has been some discussion and debate about if we are impacting and have an impact on the Earth's climate. However, scientists are also studying the impact that humans may have on the Earth's crust. So on the next slide, you're going to read an article about how humans may be impacting this layer by the use of fossil fuel. So as you read, take notes on what stands out to you because you're probably going to have a question about it. So you need to make sure that you take this, you can click on it. You're going to read this fossil fuel. Again, this is their theory. And read through this article right here. So almost all scientists agree that burning fossil fuel is contributing to climate change, but an agreement is less clear cut on how exactly it's influencing rising global temperatures. Again, this is their theory. The world is now 1 degree Celsius warmer than it was pre-industrial time. Is this solely down to emissions of greenhouse gases? Meteorologist Hubert Lamb, regarded as the father of modern climatology, argued that CO2 levels alone couldn't account for the global warming that's been observed. So his attention is turned to the role of thermal emission. So burning fossil fuels doesn't just produce greenhouse gases, it also generates heat, which then leaks out into the atmosphere. So the nuclear tests and volcanic eruptions are some examples of other large heat sources. So I want you guys to finish this, reading this, okay? You're supposed to read this. Once you finish it, in your opinion, do you believe that humans are impacting the Earth's crust? I want you to tell me yes or no through fossil fuel extraction. Tell me why or why not. So this is you explaining why or why not. If you need to pause, you can pause. And then what I want you guys to do is lastly, you're going to be taking your quiz. So remember, this is based on the lesson. You are getting graded for this quiz. If you did poorly, you can go back in and retake it. You just have to click the link and sign in. One of the last things you need to do is describe the movement of the Earth's mantle. So explain how those convection currents can cause those tectonic plates to move. So how do convection currents cause tectonic plates to move? Again, if you need to, you can pause me. How confident do you feel in your ability to explain the Earth's layers inside? Very, somewhat, confident, or not confident? And then what is the most interesting or surprising thing you learned about the Earth's layers? So let me know what the most important or interesting thing you learned about the Earth's layers. And thank you for completing this. I look forward to reading your answers and grading it. So we will talk to you soon.